Hello, everyone. Welcome to Bootcamp 2020. Today, we're going to be discussing, we're going to start with TypeScript today. Today, we have, as always, Zeeshan and Zia with us. Hello, guys.
Thank you. Thank you so much.
No.
Let's, hello everyone. We have completed the animation. Now the students are required to do project 4A and 4B, and if possible, project number 5 also. Now we are going to start because animations is more or less complete. Somebody passed away in my family. Last time I was not able to attend the class, but Zeeshan took it, and Adil, I think they completed the animation part of it. The thing is, why do we need TypeScript? That's the first question, Zeeshan. Adil. The thing is, when you are developing a large application, if you go to TypeScript website, they say a language that scales. What does it scale mean? When you have a small project, dynamic language like JavaScript are okay. What happens is that if you have a error, all the errors will show up at runtime, not at compile time. You have to distinguish between the two. The runtime is really bad stuff. What happens is that if there is an error in your code, your program will crash and the user will not be able to use it. That is the main problem with using languages such as JavaScript. Now, what to do about it? Now, what is the problem with JavaScript? It doesn't have any types. It doesn't have any, type checking. Basically, you use that application, you build that application and run it. And whatever errors will show, of course, you will test it. But when it is a small application, what you do is, let's see, it has only 3 or 4 screens. You can quickly go over it and check if everything is working fine. Imagine a large app. Each time you will have to check. There are 2 ways to check if the application is working. One is doing test-driven development. That is TDD. That is very critical. Whenever you are doing development of large applications or even small ones, everything should, additional codes must be written, which are basically testing your main application. That's one way of doing it. But that is not a question of either or. The other way is using typed languages like TypeScript. So therefore, all the errors you basically try to find out before you land the application, you give the application to the end user and before the runtime. Now, Zeeshan, would you like to add anything to it?
Yeah, basically, the most important part is whenever you are working on a dynamic language, there is no type checking. Let's say whatever way, as Sazia has mentioned, that it's always on the runtime. So whenever you are working on a dynamic language, the problem arises when you develop an application, you create a variables and a functions or whatever you did, and when a person are calling a function. So as Sarja mentioned that in large application, if you made change at some place, if it's not a type checked properly, so if you made a change at a particular location and that portion affects other portion of a application and there is no type checking, so what will happen is if you change the type into string, other portion of the application might be using as an int, but it's changed to string. So what you need to do, you can't check, you can't verify that because there is no type checking, and code will finalize as it is. Once you start running whenever user try to use it, then you are going to see the lot of errors, and those errors will be at runtime, and runtime means while it's executing in the browser, or in case of server while the Node.js code is being running.
Therefore, the best thing is to use a type check language, and TypeScript is an ideal language for that. What it does is basically it's not a compiler, it's a transpiler. Zeeshan, can you tell us the difference between a compiler and a transpiler?
The basic difference, first you need to understand the compiler and interpreter. The first thing is, whenever there is a compiled language like Java, C Sharp, or any other language which are compiled language, what that does is they check the syntax, they check the grammatical and all the syntax checking that needs to be verified before the execution. And what that compiler does is, after checking that, it convert the code into intermediate code, which is called bytecode, and that bytecode converts into the machine language at the runtime. This is what a compiled language does, like Java and C Sharp, in Solidity also. The TypeScript is a transpiler because TypeScript is built on another language, which is JavaScript. So TypeScript does not compile, TypeScript does not convert JavaScript into bytecode. What TypeScript does is it give you, you can call it a synthetic sugar. So it gives you the better view, type checking and everything. So whatever you write in a TypeScript, what TypeScript does is, its compiler, what TypeScript's compiler does is, it converts TypeScript into JavaScript. It does not create bytecode. It generates JavaScript from TypeScript. That's why we call it transpiler. Whenever you are changing the shape of a language, so you are transpiling it. So from TypeScript to JavaScript, and then again JavaScript will run in a browser, and browser will do whatever execution needs to be done as it's currently doing. So we don't need to worry about that part. What we need to worry about the prerequisite, so that we can apply all the type checking, so we can reduce as much as runtime errors as possible.
So Zeeshan, if I understand correctly, you are saying JavaScript will still run in the browser. TypeScript does not run in the browser. Am I right?
No. Yes.
Please clarify.
Okay. Basically, what you need to understand is, our browser only understands JavaScript to execute. As far as we are not a WebAssembly, so currently browser only understands JavaScript to execute the program. So the browser, let's say Chrome has a V8 engine. Recently, Microsoft launched the Edge browser. It also works with the V8 engine. Safari, all the browser have engine which understand JavaScript, not TypeScript. They understand JavaScript. So whatever you can do with any language, if you want to run in a browser, there must be a JavaScript. What TypeScript does is, you write a code. It's a exactly JavaScript syntax, but in a typed language. So you need to identify that I am declaring a number, I am declaring a string, I am declaring a function which requires two parameters, and that parameter must be number and string. So you need to specify all the types, all the syntax checking. Sometimes we use a property and we don't worry about if that property exists or not in JavaScript. What TypeScript does is, when you write that code, TypeScript's compiler check all these things. It checks if you have a specified proper variable typing, you are not assigning a string into a number variable. All this type checking is done by the TypeScript. It is called abstract syntax tree. TypeScript converts a syntax called abstract syntax tree. It's nothing but just another syntax with it excluding spaces and comment, and then with that syntax it generates JavaScript. So with the TypeScript in between, you have just one additional step. You are not reducing any steps. You are adding another step of compiling or transpiling TypeScript into JavaScript. So your code converts from TypeScript to JavaScript, and as you are currently running your JavaScript in browser or server, the code will run as it is in JavaScript. The only difference is, all the type checking has already been done. So if you have created a variable number, int age equals to 5, and the second line, if you are saying age equals to hello, so what TypeScript will do is, TypeScript at the transpilation time, it identify you that you are doing something wrong, correct it. Once you are done with it, it will generate JavaScript, and then you will execute the code in the browser, so that syntax error will not occur in Java browser.
So therefore, what we have learned so far is that whatever code we write in TypeScript, it is converted into JavaScript, which then runs in the browser. The second thing to note is that TypeScript is a superset of JavaScript. Whatever is valid JavaScript is also valid TypeScript, but it gives you additional things which you can build your application. It will not improve the performance. In some cases it might, but most cases, because the runtime, it is basically running JavaScript. What it does is basically catches all the errors, and most of the professional projects in the last year or two, or professional libraries, Zeeshan and Adil, they are currently being done in TypeScript. So therefore, if we want to train professional developers, like they must know GitHub, they must know, as we go forward, serverless application development, they must know Terraform. These are the main tools which are being used, and TypeScript is one of them. So therefore, as we go forward in this bootcamp, from now on, whether we are doing server programming or client programming, we will try to use TypeScript as much as possible, because we want it to become your second nature. At a minimum, we will take 2 classes to cover TypeScript. We will start, Zeeshan will start today, and next class, Adil will basically develop a quiz app, and that is project number 7. Actually, project number 6, which will be, Adil will do it next time with a quiz app in TypeScript. All the details are on the website. Zeeshan, let's get started.
Okay. So let me share my screen. And as you have mentioned already, we will be following this book that's already available. So first of all, let me create. Yes.
Please show the book to everyone. It is right now the best book on TypeScript in the market.
So Orally Programming TypeScript, this book is available, and you can view, download this book, and we'll be following this book so that we know the sequence we need to understand. In a sequence, we need to understand the Java TypeScript. Let me create a project.
We will not cover object-oriented programming, and there are a lot of other things in TypeScript. We will cover a TypeScript subscript subset which is required for React.
Okay. So can you see my screen?
Yeah.
Okay. So first thing first, what you need to do is you need to install TypeScript beta, which Sarzia mentioned in
because the latest TypeScript is TypeScript 4.0, and
yes.
The beta is just right. Most probably when you are going to see it, 4.0 will become the standard, but right now it is basically in beta.
Okay, so TypeScript 4.0 is in beta, and what you can do is npm install -g TypeScript beta. So it will install as an npm module at the global level, like we have did with React Create App. So
Zeeshan,
I have already done this. So
Zeeshan, in the book, they are preferring it to be used in the application itself. So therefore, they basically use npm init, and then they install TypeScript locally. But
yes,
you can do
yes.
it. You can do it both.
At this moment, I have installed it locally. So
go ahead.
Okay. So you can just type npm install exclude the G, so it will be installed in your project. And if you do not exclude the G, so it will be part of your global library. What I'll be doing is initially first I'll show you the TypeScript file without any Tsconfig or whatever the book is showing. So let me just create a file, and I'll name it as index.ts, not JS. It's a TS syntax, and you can write as JavaScript you want. So console.log, like we do every time. Hello world. It's just a console. And what
Now,
I can do
Zeeshan,
is I'll
just a
type.
second. Just a second. Please take your cursor on
Mhm.
the log. It will show you help because it is TypeScript.
Yes,
No, I'm just on the program, in the
it will
program.
show
Console, look at this. This is the beauty of it.
yes, yes. So it will show you what kind of a property you are using. So it's a function. It's asking for the parameters. So message is a parameter. It's an optional parameter. So we will see the optional parameters and everything. So at this
Wha-
moment, it's just a console and nothing else.
The good part
And
is,
what I'll do
the,
is TSC, TypeScript compilers name. You can in yes,
what I'm saying is, the good part is that it also increases the development
yes,
time, decreases the development time by half. Whenever I'm using TypeScript, it takes me half as long to
yes.
build the application as compared to JavaScript. So it catches the error and it increases your speed.
Yes, because it just does at the compile time. You don't need to worry about the runtime. Such a small points. Okay, index.ts, TCS space index.ts, and I'll press the enter. What it does is it will generate the JavaScript file index.js, and it looks very similar to index.ts. At this moment, there is nothing different in both of the code. So it's just a simple. Now let me go to, and what I'll do is let a equals to 56. So in the next line, a equals to hello. As you can see, Visual Studio Code itself has started giving me an error, but I will compile so that you can see the error. And as Sazia mentioned, you can put the cursor on the variable and it show you what type of variable it is. TCS index.tcs. What it says, type string is not assignable to the type number. So it says a equals to hello is not possible because you have created this variable a. Now there are two things. When you are
Dishan,
declaring a variable in TypeScript,
your screen is
you
stuck.
can create a
Please
variable
remove.
in TypeScript in a two-way, implicit or explicit. Either you mention a type as
Zishan,
number,
your screen isn't showing.
so it will be a number type, or if you are not mentioning as a number, so whatever value you have assigned at the initial, it will assume as a number and it always remain the number. You cannot change it.
We lost Zishan.
I think Zishan is again having internet problems.
Yeah. Checking.
Adil, please call him on his mobile phone, I think.
Yeah.
Let's see what is the problem.
Zeeshan didn't realize he was disconnected. Because when you share your screen, it uh, just keeps going. He's coming.
Hi, sorry about that. I guess my internet was okay. So where we left? Where was I when
Where
my internet was
you were
disconnected?
basically just starting to compile index.js with a error of assigning it to another variable type.
Okay. So let me show you. So at this moment, what happened is let a equals to number equals 56. So what it does is it specify the data type of variable, that this variable must be a number in JavaScript, in TypeScript. And at the second line, if you try to change its type, it will give you the error.
Zeeshan,
So
you
let
need to add
me
your screen, Zeeshan.
need to.
Add your screen. We can't see.
Okay, sorry about that.
That's okay. No worries.
Okay.
Yes, now we can see it.
So now, okay. So what we are trying to do is we are trying to understand what TypeScript will do. TypeScript, whenever I create a variable and I need to specify type of that variable. So either number, string, boolean, array, I need to specify the type. So you can do create a variable in two way: explicit typing or implicit typing. Explicit typing means you need to specify I need to create a number or I need to create a string. If you are doing explicit typing or implicit typing, it does not matter. You cannot change variable if you try to assign a different data type. Like I create a variable, let a number equals to 56, and on the second line, what I did is a equals to hello. So let me run the code compiler. Okay, so it gives me error. Type string is not assignable to type number. So a equals to hello. It says that because your variable is a variable has a data type of number, so you cannot change its type. You can use it. You can assign any other variable. Let's say I will mention it 45. So there is no problem in it. But if I try to change the data type, it will not allow. Okay. So now we can see a equals to 56. In JavaScript, you will not have any difference. JavaScript will remain the same. You do not have data type specifically typed data type to mention here. So JavaScript will remain the same. The only benefit is at the pre-stage, it will verify everything. So if I assign a number without mentioning the data type, will it allow me to change the variable data type? Still not allowed. Why? Because TypeScript assumes a type based on variable's value. So it's an implicit data type. So it's implicitly number. Either you define implicitly or explicitly. So that's how you TypeScript helps you in checking the data type of your program. Now let me move to the book. So in chapter 1, there is an important distinction the author shows us. In JavaScript, because what JavaScript tries to do is it tries to convert anything and apply logic. There are rules, but these are complex rules which, if we try to understand them, there are a lot of rule checking. So instead of let's check this out. 3 plus square bracket. What TypeScript what JavaScript does is JavaScript try to come on add two numbers, but there is only one number and other is uh, square bracket. So what TypeScript tries to do is TypeScript tries to concatenate them. So 3. So what TypeScript will do? TypeScript will convert 3 into string and square bracket into string. So at end result of square bracket is, because it's an empty square bracket, so it will be another string. So the output will be 3 directly. That's why you need to understand that if your function is accepting a number and you are sending an array, so you will not know in a larger application what is the problem occurring, because somewhere someone has changed some variable data types and your application is start crashing. So that's why you need to understand, like this is another one. We have created an object and now we are trying to use the variable foo. So what it will do is it will give you undefined, but TypeScript will not allow you. Another example, you have created a function and you are applying operation of division, but what you are doing is you're at the calling of function you are passing a string. That's again a problem in JavaScript. So you can, with TypeScript you can avoid these situations. So what we will do in TypeScript, you can hear me, right?
Yes.
Okay. So what we can do in TypeScript, whenever we try to concatenate 3 with the square bracket, TypeScript will hold you. TypeScript will stop you that you are trying to concatenate or add some different data types that are not acceptable with each other. So TypeScript will not allow you to concatenate this. So at this compile time, or what you call transpilation time, TypeScript will stop you. Again, you have created an object with empty square curly bracket and you try to access a property, TypeScript will show you the error that foo property does not exist. So instead of going at the runtime and running in a browser or on a server, it will give you one whenever you try to compile it. So it's a pre-stage. In the function, what we do is b colon number. So we have especially specified that we are accepting a number in this function. So if you try to call function with this string, TypeScript will not allow it. Let me just give you the example with this object and then we will move. Okay, so let obj equals to, and there is nothing inside it, console.log obj.foo.
Therefore, as you can see, the errors are caught at compile time, not at runtime.
Okay, so you can see error property foo does not exist on type. So our type is a square bracket. So what it's saying is, sorry. You're saying something, sir?
No, nothing. Go ahead.
Okay. Okay. So in case of obj.foo, it restricts you that you do not have such property and you cannot use it. So in a larger application, you cannot just randomly pick any property and start applying values over into that. Now, if I create a foo colon hello, it will work. And you will see code like this. So in JavaScript, again, you will see the old style code. Now, if I try to obj.foo equals to 56. So what I'm trying to do is I'm trying to change the data type of foo property. Again, type is number is not assignable to type string. So it says 56 is not assignable to string. So again, it's an implicit conversion. So the foo property is a type of a string now for the life of a project, and you cannot change it, and you cannot assign any other value to it, so that it will give you the some sanity to your code. Okay, let's move forward. Chapter 2, we have discussed the compiler. This is what does TypeScript does. You create a TypeScript code, you write a code in TypeScript, then abstract syntax tree. It generates abstract syntax tree, which is in a code again, but it does not have, let's say, comments, spaces, or it removes all the useless things, and you have a simple plain code. Then type checker will applied. So your type checking is done after your code is converted in a tree, syntax tree, abstract syntax tree, and then type checker applies. It checks the type of your variables, functions, and everything. So the second stage is the type checking stage. After that, your syntax tree converts into JavaScript. Now from the JavaScript, again, it's the previously how it was going to be done. It's again will be the same. JavaScript source convert to the JavaScript abstract syntax tree, then abstract syntax tree to bytecode, because your system, your memory does not understand JavaScript. It understands machine language. So first we generate bytecode, and then that bytecode is converted into the runtime, converted into the machine language at the runtime. Okay, so type system I have already discussed that let a equals to number. Let me increase the size. So you can create a variable like let a colon number. So string, boolean. If you want to create an array, so you need to specify boolean square bracket. If we remember, or we have done lot of many time, that whenever we need to create an array, let I say square bracket just as it is. But now what you can do is you will say number array.
It is recommended that most of the time you do not do explicit
Explicit
typing,
type.
but do implicit typing. This is not recommended way, but the recommended way is this.
So you can, what you can do is you can just create like this, and it will understand that it's a number type array, and if you try to change at any point in time, it will not allow you. So you got the idea that basic what you need to understand with the TypeScript is it gives you the sanity of your code, type checking, syntax checking, so that you do not face the silly errors at the runtime. This is implicit casting, implicit typing. Okay, so what it says, it has given us in a table that shows the features and is it available in TypeScript or JavaScript. What, so how the types are bounded dynamically. Whenever you the line of code being executed at that time, it decides it's a number or a string. In TypeScript, at the compile time, it decides that it will be a number, so it checks beforehand. Are the type automatically converted? Yes, you can convert into string, string to double, boolean, anything. In TypeScript, it's not allowed. Mostly, there are cases when types type when at what time type checking is being done. In JavaScript at runtime, in TypeScript at compile time, like I was doing ts space file name. So what I'm doing is I'm trying to compile it. Actually, it's a transpilation, but we call it compilation. So it does checking at the compile time. When errors are surfaced at runtime mostly, and in case of TypeScript at compile time mostly. And these are the syntax errors, or what you say, your grammatical errors, which your language does not allow and you are trying to do. So those are the errors which occurs at the compile time. But sometimes logical errors, user input errors will also still occur at the runtime, and it does in any type language as well. Okay. So when types are checked, we have verified this, we have seen the error as well. So type hello. So you just don't need to compile as well. Your this is ID feature. That's not TypeScript feature. This is a Visual Studio Code's feature that it shows you the error, and it can be done by Visual Studio because TypeScript is type language. Otherwise, you cannot do this in JavaScript. Code editor setup. Okay. Now what we need to do is, at this moment we are working on a simple single JavaScript file, TypeScript file. So that's not an issue. But when you are working in a large application, so you will have a multiple TypeScript files and you need to convert them all into JavaScript. There'll be a moduling. One file need to be access the object or properties from the other file, or any of those things. So what you need to do is you need to have in a TypeScript project a file called Tsconfig. It provides the options, how your code needs to be compiled, where the output should be placed, where the source should be to be checked. So again, as we did in React, and we are going to do in TypeScript, that from now on you need to have a proper project structure. In that we will be working. So always, in current scenario, we will always be creating a npm project, so that our project will have all the dependencies into it. So what I can do is, what I'll do, I'll go to the folder and I'll type npm init first. What npm init will do is it will create a package.json file. It will ask project name, what project you need to do, so that as we have done in the React. But for React with the npx create React app, it does everything by itself, and you saw the package.json file over there. So I'll type npm init. What it will start asking me a few questions. What you need to name it, the name of the project. Let's say I'll be doing shoe store, just a name. Version 1, description, no problem with the description. Entry point at this moment, index.js. We can change all these things later on, so we just move on with the basic structure, and it will create a package.json file. So what you do, you call npm init, it will create a basic project structure. So package.json file. It has a name property, version, description, main, index. It says what is the main file of the project, and these are the basic information. Now what I need to do is I need to install TypeScript and TypeScript node. TSLint has been deprecated in favor of ESLint. So at this moment, I'll just uh, it will take time to install, so that's why I'm not doing the npm install, but you can do this. tslint will not work, you need to do eslint. Okay, now you need to create a tsconfig.json. For the tsconfig.json, what you can do is, where it is, yes, no. There is a command, let me type it directly. tsc space minus minus init. So it will create an initial tsconfig file, which will have a lot of properties you don't need to worry about. In the future, you might use it. So ts init created a tsconfig file. There are a lot of things in this file. So at this moment, we'll focus on the only few which are mentioned over here. Library, module, out directory, strict, target. So what includes is src. So as I mentioned, that there can be multiple ts file in your project. So keeping it open-ended, we do in React, we create a component folder and keep all the component in same folder. So in case of TypeScript, when you are working with the TypeScript in a compiled language, there is a standard practice that you create a source src directory, and all the source for code file should be in that folder. So what it says to the compiler, that all the TypeScript file will be available in src folder. So don't need to worry. It says to the compiler, don't look at any other place, just go to the src folder and compile all the ts file inside it. Another, it's a library. As you know, that with JavaScript, there are a lot of recently there are many changes with the JavaScript specification, which you call ECMAScript 6, 7, 8, 9, and ECMAScript 5. So at this moment, what it says, it when you try to convert your TypeScript into JavaScript, consider converting based on ECMAScript 5. So you can say it ECMAScript 2020. So it will convert based on ECMAScript 2020. So that means there are some features that are available in ECMAScript 2020, so it will be working with that, otherwise it will not. Module, common JS. So whenever you work with the project, you need to access one file into the another. So what type of module you need to use, there is a different type of modules which you need to do. So at this moment, we are just focusing common.js. We are not understanding that what type of modules we have, and it only affect how you export your file and how you import your file. So module affects how you import and export. So at this moment, I'm not changing it. Out directory, where that output should go. So as we can see at this moment, as soon as I transpile the code, it generates the index file right besides or with the index.ts file. I can specify a separate folder, so it will generate the output over there. Source map, once you will understand the large application which are running in a browser, then you can understand the source map, that if it generates a separate file, you do not understand the code, but it gives you the better view of the file. So at this moment, ignore it. Strict true, so it says strict type checking. Target, your target should be ECMAScript 5. So all these things are already mentioned over here. Target, ECMAScript 5, module, common.js, strict to. What it does not have is out directory, so I'll uncomment it. Out directory, so I'll say dist, so generate a distribution directory and put the all the generated code over here. Root directory, which will be your source directory, so I'll say src. Now let me delete the js file, create a folder name src, move the ts file over there. Okay, so now my ts file is inside the source folder console.log arr1. Okay. Now we don't need to do anything. We have tsconfig file, we have package.json. I just run the tsc enter. I don't need to specify the file name index.ts because all these things are mentioned in tsconfig that you need to pick all the files from the src directory. So you can see it just generated the distribution folder dst and it has a JavaScript file. This is how you there are all lot of other configurations. We'll not going into those details at this moment, so you can just understand that always create a source folder for your TypeScript and generate the output in a particular folder so that you can easily handle that. Okay, sir, you want to add anything or I should keep going?
Keep going.
Keep going. Okay. Okay, so as I have already showed you how we can create an index.ts file, and then this will be our project structure. As you can see, we have a distribution source folder. We don't have node module at this moment, but we will have in future once we are using a lot of libraries. Okay, so now you can see you call the ts and it will generate the index.js file in distribution folder. If you want to run that file, what you will do is in case of node.js, you type okay, what I was showing you, yes, node dot slash distribution folder slash index.js. So it will run this file, whatever inside this. Now I can just let me show you how we can use with, if you want to use with the web application, just a simple example so you can understand. HTML file, I just created a folder. Okay, so I just created index.html. There is nothing special, just reference the JavaScript file as we done previously. There is no difference. Index, okay, dot slash distribution slash index. This is how you are going to use. So you will compile the code. So TS will convert into JS, and wherever you want to use a JS file in simple JavaScript with simple web and HTML JS project, we'll see how it will work in React. Okay, so next we have okay. So what now we I have already discussed quite many times. Let a equals to 1 plus 2. Let b equals to a plus. These are the examples I have already shown you. So let me move forward. All about types. So let's move to the discussion of the types. So as we have started with the explanation that you have a type checking in TypeScript. So you can specify the type while creating a variable, declaring a variable. So to declare a variable, There are a lot of types available. The type which is available at the top level, it's unknown, and you can define a type which is unknown. And there is a very rare cases when you need to specify your type as unknown. That means you don't know the type of your variable, and you cannot use that variable without condition checking. So we'll see if we reach out at this point today. Then you have undefined, void, any, null. Any, again, it's exactly like we have JavaScript. In JavaScript we create any type of variable and provide any value, so any is the same. Number, big int, boolean. Big int is available in JavaScript 2020. So if you are using ECMAScript 2020, then you can use big int also. Boolean, string, symbol, object. You can create enum as well. Enum is not available in JavaScript. So what TypeScript will do is it will convert it in JavaScript, and then you can use it. It will create a simple object to use an enum in that. Array, function, constructor, tuple. There are a lot of data types. Now you can see this example. Function is square of n, and n multiplied by n. So what it does is, if you provide the 2, it will evaluate to 4. If you provide a string, JavaScript will not complain you. JavaScript will not say anything to you.
I think we lost Zeeshan.
Yeah,
You'll have
we
to
just
call,
lost.
you have to
Call
call
him.
him.
Again, yeah. Okay. I'm also having connection issues today.
Yeah. Because of this COVID-19, a lot of people are using internet. Therefore, there's a lot of load on the internet.
Yeah.
Hi, sorry about that. My Zong device problem has not been corrected yet. Okay, so where were I?
Can you add the screen again?
Okay, let me
Zeeshan,
screen.
we also have another problem. You have another application running. I think girls are sending you a lot of messages, and then they create a lot of ping. So I think I suggest you wait for 15-20 minutes to talk to these girls.
So, they need to be waiting.
They have to wait.
Yes.
They all find out he's live and then they message him.
Okay, so where was I in explaining when we lost the connection?
Yeah, you were here.
Okay, so in case of here we can see we have created a function. Function is square root of, and it asks for a variable, and you multiply those variable and return a value. In simple JavaScript, there is no problem. If you try to convert, if you try to call this by passing a 2, it will result you 4. If you try to pass a string, what JavaScript does is it does not complain you. JavaScript is kind of what you say, it 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 helps itself and try to convert it anything it want. So what JavaScript tries to do is, because there's a multiplication signature operator, so JavaScript try to convert string into number. Because the string is this string is Z, it is not convertible into number, so it will generate NaN, and then NaN multiplied by number results NaN. That's why it evaluate to NaN, and it will not give you any result. Okay. Clearly this function, okay. So what we can do is we can specify type in a function that we are accepting a number. In this case, now what we'll do is what TypeScript will do.
Here's a result from the web.
It will not function.
Sorry, I don't understand.
I think
I think that's not the girl you were talking about, was it?
it just started Android square of, and what I'll do is I'll say n colon number. Now I can do return n multiplied by n. At the time of calling this function, I'll pass 4. It will not give any error. If I pass any string or any value, so what it will do is argument of type string is not assignable. Argument of type string is not assignable to integer, so a number, because we are using the data type of argument is number, so it gives you the error like this. So in case of JavaScript, there is no difference. Let me call it with 5. Let me see the show the output. It will compile. And you can see in case of JavaScript, you have same function. There is no data type in JavaScript. Only at time of type checking, TypeScript will check all the types, and you can specify this type while applying. Okay. So what we can do now, if we call square of ABC of types. Okay, so now we can move to specifically each type. If you need to add anything, sir, or I can start discussing.
Go ahead.
Okay, so as we have already discussed a lot of types, int, number, boolean, we have already discussed in this explanation, but there is a type named any. As we have seen in case of let a colon 56 or let b colon number equals to 78. This is how you create a variable, and TypeScript assume its number data type. Now what you can do is you can apply any operation over it, but if you don't know data type, if you want a type which can accept any value, even in TypeScript, so you can create let c colon any equals to 89. Let me first show the output, and then we can add more changes. Okay, so let's compile it. Okay, so it generates the data output, and A, B, C, there is no difference. There is A, B, and C. You can see the 3 different variables. Now what I can do is, in case of B, I can, if I try to assign a value of a string, so it will give me error. If I try to assign C equals to hello,
Therefore, the bottom line is, if you assign a variable type any, it basically becomes JavaScript.
Exactly. So it will allow you to change the value and you can work it as you want. There is no error. So any can be, if you don't know the type in advance and you want to keep the variable dynamic. So in TypeScript also allow you to create such variable, but you need to specify that it's an any type. If you remove the any, then it's not an any data type. It's in a number data type. You need to exactly specify. So again, by specifying any, TypeScript will know in advance that there is a type which can accept any value.
But it is recommended that you should avoid trying using any most of the time.
Yes, definitely. It's what you say, again, backward compatibility. If you want, if you are working in JavaScript and you can't think of any solution of it, so go for the any. Okay. So as you can see, what it says, let a any equals to 666, let b any equals to square bracket danger. Now if we try to combine it, as it's a TypeScript, but what any does is, any exactly does like a JavaScript, so it will concatenate it 666 with danger. So you will see the output. It's not showing output, but you will see 666 plus danger. You will see output like this. Again, unknown. What this book says, if any is a godfather, then unknown is a Keanu Reeves and uncovered FBI agent. So in that case, in case of any, it's like you have uh, you want to create a variable which can accept any data type. In case of unknown, it's not a kind of variable that you need to keep different data types into it. You just don't know the type initially of that variable, and whenever you want to use that variable, you need to apply some kind of conditions. As you can see here, let a equals to unknown 30, let b triple equals, it's comparing a with 1 2 3, it will work fine. Now you are trying to apply an operation a plus 10. You are trying to apply an operation on a variable a. So TypeScript will not allow it, because TypeScript will say that this is an unknown data type. So we do not understand what data type it is. So use it in some kind of condition. So you do not know. At this moment, I myself unable to think of any situation where I didn't know the, if I don't know any data type, I will use any. I am not sure where I'll be using unknown, but we have this data type, and we can apply this type check, and then we can apply operation on it. It's working, right?
Yes, it is working.
Okay. So that's how you use unknown, and it says whenever you want to use it, you want to do any operation on it, you need to use it inside a condition. So you need to first check data type of it or any conditions, and then you can use it. You cannot directly use unknown variable like this. It will not allow you. Boolean, again, true and false. All these are the normal things. The special thing is, let e true equals to true. That's something, what you call, let's say, let a equals to true, that's normal. Let b equals to colon boolean false, that's normal, and you can change it. B equals to true. What you can do is, let c colon true equals true. It's allowed. And the good thing is, let me first generate the output. So here you can see var c equals to true. So there is nothing much different. Now what I'll do is I'll c equals false. It will not allow me to change the value. So in a way, it is creating a constant data type. So type false is not assignable. You are actually creating a true type, and it accepts the true. It same applies with the int. You will see later on. But let ABC colon 20 equals 20. So you are creating a constant variable with the value of 20. So there is you have a read-only property, you have a constant, but again you have this style of creating a variable. At this moment, again, I am unable to think of a situation. Number, again, you can create number. For the larger number in million, generally what we see in financial application, we need to understand the value. If a number zeros are too much, so we need to understand million and billions values. You need to better have a comma in the figure. So in programming, you cannot apply comma in values. So what you can do is you can apply underscore. So it will just create, and output will be like this in JavaScript. So you can see TypeScript with that. You can easily understand, yes, it's 1 million. Again, big int is not available in ECMAScript 5. It's available in ECMAScript. It's a newcomer in JavaScript and TypeScript both. So you can, if you want,
let's skip it.
Skip it. Okay. Okay. So string, again, string we have used so many times. So there is a simple, you create a variable with a single quote or double quote, however you want to use it. Symbol, again, it's in a new data type, and you can create a symbol of your if you want to do something, you want to create a symbol like in a cryptocurrency applications, you can create a symbol with ETH and Bitcoin BTC. So you can use this data type in such applications. Objects, what you can do in objects is exactly let me show. Okay, so let my obj equals curly bracket, and as we have seen a moment before in our previous example, console.log name. Okay, my obj dot. It's a normal, and it will compile, and it will not give you any error. But if you try to use my obj dot hello, it will give you error because there is no such property hello. In JavaScript, you whenever you are creating a big application or working with the server side, you will have lot of usage of such type of objects, which you will be creating with the curly brackets, and you will be receiving objects in this way. You will be submitting object. You will be creating object in this way. So TypeScript allow you to create a type specific object so that you can specify structure beforehand, that what type of variable should be available in this object. Check this out. Let a colon curly bracket b colon number. So what this says is, create a variable a. It should have an object which has a single property b with the data type number. So now you can create an object which must have a b property, b type of property, b property with the type of number. So as we have done this, let me keep it as it is, and let ABC colon, or we can call it a, let's say call it user. name colon string. What I'm doing is I'm creating an object. It's just a declaration. I have created a user object, and it can accept one property name. User.name equals to hello, or I can do is user equals to it works fine. But if I'll try to add a property age colon 56, it will give me, you can see error directly in VS Code, so you don't need to worry about the compiling. It says type name and string is not assignable, so you do not have the second property available. What you can do is age colon number. Now it will work, and you need to give the comma. So you can create an object before, you can specify the properties inside object beforehand. So when you are assigning an object to the variable, it gives you the type checking and all the property checking, so that you do not, let's say an object is coming from the server, and you specify that only name and email property should be in that object. If you receive an object which have multiple properties, more than these two properties, it will gives you the error in case of TypeScript, but definitely that will be the runtime case. As you can see, let's see colon first name last name curly bracket ends equals and curly bracket start. So you can create variable directly. Let obj2 colon first name string email string equals again curly bracket, and then I can assign first name to any string and email to any string. I cannot type number, it will give me an error. Again, you can see this. hello@gmail.com will work fine. Let's see the output. In case of output, you have simple JavaScript object as you were doing with the normal JavaScript, because with TypeScript there is only type checking, and once it generates the JavaScript, it needs to have a pure old JavaScript. So you will see the same old syntax. There will be no typing and everything available over here. Optional properties. Yes.
We are basically running out of time. Let's complete. How much pages left in this chapter?
Chapter 3 is quite a long.
Let's stop here, because the students must be tired. We never get tired, but the students might be tired.
Okay.
So therefore, we will continue in the next class, and Adil will also start working on the quiz app built with TypeScript.
Okay.
Thank you, everybody. Thank you.
Thank you.
See you, all of you, soon.
Bye. Bye.
Bye.
Thank you. Bye.